Hari Om. So in last video we have seen about resistors. Today we will see the heating effect of electricity. So electricity is a form of energy, right? So electricity is form of energy, and what is electricity? When current, the charge will flow, right? That is only electricity. So we say, what all formula we have learned? I equals to Q by T, right? Correct? So this is current. Then what else formula? V equals to W by Q, right? Correct? And we discussed that work can be replaced by energy, right? Energy and work both are same because unit of electricity is joule and unit of work also is joule. Correct? Huh? So here if you see, here this equation we use to derive that heating effect of electricity. So potential difference is work by charge, and we want work or energy, both are same. If we want energy, can we say that energy equals to VQ? See here properly. Can we see? Okay. Here energy is equals energy by charge equals to V. So write like this: V equals to work or energy by charge. So what is energy? V into Q. So I have written energy equals to V into Q. Correct? Now energy is VQ, and recently we have seen what we have seen. Ohm's law. So what is Ohm's law? V equals to IR. And from here, what is Q? From this equation, what is Q? Q equals to IT. IT, right? So in place of Q, can we write IT? Yes. So what will get energy? V into IT. Okay. So actually, this one energy formula we derived from earlier formulas. What was earlier formula? Current equals to charge by time. What is current? Rate of flow of charge. So I equals to Q by T. So what will be Q? I into T. And here potential difference is W by Q, or energy by Q. So what is energy? VQ. So energy is VQ. And then
energy is VIT.
Energy is instead of Q, IT. Correct? Correct? Now heating effect we say. So heating effect means heat is also form of energy. Right? Why we are taking specifically energy equation only? Because heat is also form of energy. Correct now? You know that energy can neither be created nor be destroyed. It can just transform to one form to another form. So heat is also form of energy. Electricity is also form of energy. Correct? So that's why we have taken energy equation. Understood? Huh? So energy is VIT. Now Ohm's law. What is V?
IR.
IR. So write instead of V, what we should write?
IR.
I R. Then
IT.
IT. So I into I. I square. I into I is what?
I square.
I square
RT.
So what is energy?
I square RT.
This is only heating effect of electricity. And who has given that? We say Joule's law. What we say?
Joule's law.
Joule's law have been asked in exam many times, in board exam. What is Joule's law? If they ask about Joule's law, what you will say that heat energy is directly proportional to square of current. What is I? What is I? Current. What is R? What is T? Time. So this heat energy you can write HE, heat energy directly proportional to I square. Correct? So this is mathematical way to write. In English, what you'll write? Heat energy is directly
Directly
proportional to
proportional
square of current. Correct? Then heat energy is directly proportional to resistance, and heat energy is directly proportional to time. Now use common sense. If you, for long time, if you pass electricity, you will get more heat. Correct? Huh? So the heat depends on square of current, resistance and time. Understood? Any doubt? So I square RT, this is only Joule's law. You can see in NCRT it is given that Joule's was the person who said about this. So we say it is Joule's law. Any doubt?
No, sir.
So actually, energy we have, now here students get confused. Sir, we have so many formula. How to remember in electricity? If you see properly, we have only two formulas. One formula is I equals to Q by T, and that also is simple, we know. And then V equals to W by Q. From this we got E equals to VQ. Then from here we have here Q equals to IT from this equation which we know. Here we got E equals to I square RT, right? Now what you should remember, this is kind of derivation, correct? Now in exam, why you'll derive? In exam the last question you have to solve it. How to solve? Simple. You should know that energy, work or energy. Which energy we are talking about? Energy, electricity, electric energy equals to VIT. This you should know. We got, right, last slide if you see, we got first VIT only, right?
Yes, sir.
E equals to VIT. This we got, no, first, when you, Q if you replace with IT, you will get VIT. Now, this is important. If you know this formula, next we'll see power. Power also you'll be knowing, and energy also you'll be knowing. So only this formula you should know. And how to remember this? How to remember this? Shortcut, I always say that energy, you remember like that. Vellore Institute of Technology. There is one college, engineering college, VIT, famous. Okay, Vellore Institute of, don't write in exam Vellore Institute of Technology. This is just to remember. VIT, Vellore Institute of Technology. Understood? Huh? So this VIT, if you know this, over. Now, energy is VIT. Another one, using Ohm's law. I said last class, Ohm's law is soul of this chapter. It's very, very important. Everywhere we use Ohm's law. So what is Ohm's law? V equals to IR. So just now circus. What is the circus? Instead of V, what will you give? IR. So it will be what? I square RT. Instead of V, we will keep IR. So we will get I square RT, which was Joule's law. Correct? Now next is V we replace with IR. What I can replace in place of I? V by R. So here reference is this equation. This is important. So instead of V only, instead of I, V by R into T. So what we got? E equals to V square by R into T. Understood? Huh? So that's why they say there are so many formulas. Students complain in this chapter, so there are so many formulas. There are not much formula. Okay, all are interlinked. We have first derive work, and it is VIT. And here we have just substituted Ohm's law in that, instead of VIR, so we got I square RT. Instead of I V by R, we got V squared by R into T. Any doubt in these three formulas?
No, sir.
In energy,
Mhm.
work or energy means these three formula, correct? Now next and last part of this chapter is power. What is that?
Power.
Power. Which power? Electric power. What is power? In 9th standard they will teach. Power equals to work by time. Power equals to work by time. So work is what?
Work is.
So what is work formula? We have just seen three formulas. See here properly. So work is what? What is work formula? VIT. Just I said Vellore Institute of Technology. VIT by time. TT cancel. Correct, huh? Work by time is power. And work is VIT. So TT will get cancelled. What is power formula? VI. Now don't think all are different and separate you have to remember. No. If you remember just one formula, what is that formula? Energy equals to VIT over. So if energy is VIT, power will be work by time, energy by time. And it is VIT by T. TT will get cancelled. What will be remaining? VI. Now if you take another formula, I square RT, Joule's law, I square RT is work divided by time. So what you got?
I square R.
I square R. One more formula. Last slide.
V into V by R.
What will V square?
V square by.
V square by R into T divided by T. Again TT cancel. What will get? V square
by
by
R.
R. Now this much. Okay. Instead of remembering this thing, what I'll tell my students? Remember this, remove T in case of power. Power is what? Energy by time. So if you remove time, it will be power. Understood? Huh? So this work or energy is VIT. Remember this. 2 o'clock night also if somebody will ask, what is the energy formula? Electric energy, you should tell VIT. Okay, what is power? VI. Then another formula, I square RT. Remove T, it will become,
I square R.
which is what?
Power.
Power. Just remove T. Is there more formulas? No formulas, right? Just one or two. So please don't be in impression that there are many formulas in electricity. It's very simple, very easy. Okay? So, understood? Huh? Simple. Three formulas are given, but if you know VIT and Ohm's law, you'll be able to do. Now if you see NCRT, there is something called fuse. Do you know about fuse? Where we use fuse?
Electric.
See, heating effect of current we have done. VIT. H equals to VIT. What H? Heat energy. VIT. Then coming to here, I square RT. We have done that. Then asan question. Current P by V. Correct. P equals to VI. Correct. No? We have done power equals to VI. Then coming to this part. Practical application of heating effect of electric current. From here one question this day they ask. See here, strong metal with high melting point such as tungsten. Tungsten has 3380 degrees Celsius melting point. Okay. So what we do is used for making bulb filament. Earlier days, now the LED is coming. Earlier days what we were using? Filament bulb. Now also many people are using. So in that tungsten they use. That filament you are seeing, that filament. What will happen? The electricity will go, it will get heated and it will burn. Okay, burn means it will give you light. So 3380 degrees Celsius. That's why they use this for filament. Understood? Huh? Now another common application of Joule heating effect is fuse. Filament, you know. Now what is fuse?
It will be in the
Fuse is used in electric circuit. If no fuse, suppose you are in house and there are AC, refrigerator, big TV, 132 inch, 132 inch, big, all size. Now what will happen? What will happen if there are so many things in house and if somewhere short circuit, there is a chance that all equipments will burn. So what to do for that? We should protect. So what we use? We use fuse. Okay. Fuse we use, and then fuse is 20 rupees, 10 rupees, 20 rupees. And we use purposefully fuse to melt it. If anywhere more current, anywhere alteration in current, what will happen? It will produce heat. We have seen heating effect. So when it produces heat, what will happen? The next thing, what will happen? After heat, it can melt, it can cause fire, it can burn everything, all the appliances. So what we use? In electric circuit, we use filament. We use fuse. So that fuse, what it will do? Fuse will melt. We want to melt it. So that when fuse will melt, what will happen? The electricity will not pass. Understood? Huh? If electricity will not pass, your all appliances will be safe. If we don't use fuse, one by one all appliances may get damaged because all are connected in parallel. Understood? Huh? But fuse is connected in series, and what we do, whenever there is any change in current, it will melt, and when it melt, it will break the circuit. And you know that electricity will not pass if circuit is broken. If you off the switch, you will not get the current. The reason is switch will break the circuit. Like that, fuse also will break the circuit. Understood? Huh? So it will protect us, from damage, and then it will regulate this thing. It will, save our this thing. Fire hazard and all will be not there. Many of the case you might have heard about hotel or restaurant or this theater, movie theater or auditorium. They get catch fire easily. The reason is electricity, electric short circuit. So how to avoid that? Use fuse, MCB, MCCB. Nowadays we are using many things. And suppose you are getting current 4.5 ampere, which should flow in the circuit. Now you should use fuse of little more than that. Like 4.5 means you should use fuse of 5 ampere. Understood? Huh? If you use 20 ampere, no use. Fuse will not melt only. So suppose if I use this one, smart board, right, DG board. Now we have to protect this, so we use fuse, okay. And suppose it requires if it requires 4 ampere current, so we use fuse of 5 ampere. In market you will get fuse of many ratings, okay, 2 ampere, 3 ampere, 5 ampere, 6 ampere, 8 amperes, like that fuse you will get. If you go to purchase fuse, first they'll ask how much ampere fuse, what is the rating. So what we do, if this DG board uses 4 ampere or 4.5 ampere, we use 5 ampere fuse, so that if current, by any chance, if current is exceeding 5 ampere, the fuse should melt. Understood? Huh? So that's why we connect, fuse is placed in series. Okay, and what it does, it protects the circuit and appliances by stopping the flow of unduly high electric current. Understood? Huh? So that's all. Electric power we have discussed. Like that I have explained you 1 watt. What is the SI unit of power? Watt. Understood? Huh? And what is SI unit of potential difference? Volt. Understood? Huh? What is SI unit of this one? Work or energy? Joule. You should know that. So if they ask 1 watt means 1 volt into 1 ampere. VI. So VI means 1 volt into 1 ampere. And the last part is commercial unit. See, in a commercial unit of energy, like in our home, we purchase electricity, right? We have to pay bill. If you don't pay bill, what they'll do?
They'll cut the current.
They'll cut the
Electricity.
electricity.
Service.
So how you will measure that? See, power SI unit is watt, and power is equals to work by time. Correct? Now, commercial unit. What is commercial unit? Commercial unit is what? Kilowatt hour. Okay. Now the meter which will be kept in every home, that meter will measure energy. So I think last to last year they have asked question. Okay, that how we measure the current in our home. Okay, that device which is used to measure the current, it measures what? They have given option: power, energy, voltage, current. So answer is what? Energy. What it measures? Energy. Why students get confused? Because they see here, what they see here? Watt, kilowatt hour. When they see watt, they get confused. But you use little brain and tell me that can we say that work or energy? Can we say that energy equals to power into time? Energy equals to what? Power into time. This is important. Energy equals to power into time. Now, if you have power 1 kilowatt in how much time? 1 hour. Then you will have 1 kilowatt hour energy. Understood? Huh? So energy is power into time, and power unit is watt, SI unit, but commercial unit will be kilowatt into 1 hour. So 1 kilowatt can somebody say that 1 kilowatt means how much? How much watt? Kilo means 1000. So 1000. And here time will be second, SI unit, but commercial unit time will be in hour. So in 1 hour, how much second? 60 into 60. 1 hour equals to 60 minutes, and 1 minute equals to 60 seconds. When you multiply, you will get 1 kilowatt equals to 6 into 6, 36. So you will get 3.6 into 1, 2, 3, 4, 5, 10 power 6 joule. This is relation. Sometimes they ask directly this question. 1 kilowatt hour equals to 3.6 into 10 power 6 joule. We have derived it. What we have done? Kilowatt we converted into watt, and hour we have converted into seconds. So 1 kilowatt hour equals to 3.6 into 10 power 6 joule. That's all. Electricity theory part got over. Okay, theory part we have done, I think, 5 parts. In 5 parts we have covered all the theoretical portion of electricity. Quickly we can summarize in first part what you have seen about current, charge, correct? Second part potential difference. Then third part Ohm's law. Fourth part about resistance and combination of resistance. And then this is the 5th part, when we have seen about electric current, electric energy and power. Okay, I hope it is clear. Keep learning, keep shining. Hari Om.